Alright, here we go. This is Math 2, Unit 12, Lesson 1A. Looking at quadratic graphs and their properties today. Hopefully in class today you talked a little about a couple key terms. You talked about things that are curved like this, and we call that curve a parabola. I'm going to make that nice little curve like that. And today we're looking at different parts of it, of what a vertex is, which is going to be kind of the pointy thing here and here. A maximum is going to be if it's going to be like a high point or a low point, depending on which way this is curved. I'm going to look at a little bit, a couple of words here today. It can be domain, which are going to be the x values, as well as the range, which will be the y values, and that are part of the function here. And that's essentially what we're looking at in this lesson. Okay, so the first one says, identify the vertex of each graph and tell whether it is a maximum or a minimum. The vertex right here is going to be on this point, which is, here is our y-axis. So we're going to be going over 1, 2, negative 2, and up 1. So our vertex is there. And because that is on the bottom end of this parabola, we would call that a minimum. Over here, our point is at 1, 2, 3, and up 2. So we're at 3, 2. That is our vertex. And because it is the highest point of that parabola, we would call that a maximum. For number 3, graphing this function here. A couple ways to approach it. I like to just kind of pick some basic numbers. Depends on what I'm looking at here. For this one, I went ahead and just picked negative 1, 0, and 1. Because these are squared, which means a parabola, I really don't need to do both negative and positive because it's going to reflect over the line of symmetry, which is going to be part of the vertical thing. I'm going to reflect over the y-axis here. But for now, that's my x value. This is my f of x, my y value. If I plug a negative 1 in, negative 1, 5 times a negative 1 squared. Negative 1 squared is 1, and 1 times 5 is 5. Let's plug a 0 in here. This equals 0. And a positive 1 would be 5 times 1 squared, which still equals 5. So if I look at those values there, and just kind of do a brief little sketch here, this is negative 1, 0, and 1. And I have 1, 2, 3, 4, 5. At negative 1, I'm at 5. At 0, I'm at 0. And at 1, I'm at 5. So this graph would have a shape like this, going up and down like that, and around it goes. Doesn't have to be perfect, just the idea is I have a couple points, and that's what that looks like. Because this is positive here, positive 5x, it tells me I'm going to be curving up like that, making a U. Whereas when I look at number 4, it's negative, which tells me my answer should be going down. So let's take a look at number 4. Number 4, I could use the same type of numbers, negative 1, 0, and 1. Alright, here's my x value, my f of x value. So negative 3 times a negative 1 squared, that becomes a 1. 1 times negative 3 is negative 3. 0 is 0, and again it reflects over the y-axis, so that's also negative 3. So when I plot this out, here's my 1, here's a negative 1, here's a positive 1, and I have 1, 2, 3. I'm going down this time. So at negative 1, I'm at negative 3. At 0, I'm at 0. And at 1, I'm at negative 3. So this one's going to curve this way and go down like that. Again, it's a negative value, so that it curves. My vertex would be here at 0, 0. And we would call this a maximum because it's curving down. Whereas over here, my vertex is also at 0, 0, 0, 0. And we would call that a minimum because it's curving up. When I look at number 5 and 6, the same kind of idea, except now I have a little fraction here to work with here. Again, I'm not going to go ahead and work it out. I'll let you figure that out, but you can tell here it's a negative value, which tells me I'm going to curve down, and it's going to have more a point to it. But at some point, it'll look like that, and off we go. It's a 0 there, so it's going to have a vertex. The point's going to be at 0. This one, with a 0 here, I'm going to get a 0 value, and a negative, I'm also going to curve. It'll look something like that. When you sketch that out. But again, do your x and y values. This one here, you might need to go a little further. You could do a negative 2, negative 1, 0 on your t-chart. It's up to you how far out you want to go. I only went that far, and that was just fine. That gave me a negative 2/3. It gave me a, negative 2, negative 2 and 2/3, and then a negative 2/3 and a 0. So I'll let you figure that out and work that out, but that's the idea. It should look something like that when you sketch it and graph it. Next section. deciding which one is from widest to narrowest. Essentially, when you look at them here, so if you look back at our previous problem, the smaller the value of the coefficient in front of your x squared, the wider the graph is going to be. So when I had a 5x, it was a little skinny. When I had a 3x, it got a little bit wider. Granted, these aren't proportional. And when I have these negative, fraction numbers, it got even wider. All right. So essentially, if I want to go from widest to narrowest, I want to put them order from smallest leading number to largest leading coefficient. All right. So let's look at number 8, for example. I have a 1/3, I have a 3, and I have a 1/6. All right. So my smallest number is going to be the 1/6. My next smallest is going to be a 1/3, and my final smallest would be this one here. So my order for this one should be written out as y equals 1/6 x squared, y equals 1/3 x squared, and y equals 3x squared. Again, widest, the smaller the fraction is, the wider that parabola is going to look. Okay? All right. Graph each function. All right. Same idea as before. So make a little t-chart here. And I can make this at 0, 1, and 2. Okay, I'm only going to do 3 terms because, again, this is a parabola, so it's going to curve for me. Here's my f of x. When x equals 0, then I get 3. When x is 1, 1 plus 3 is 4. And when x is 2, 2 squared is 4. 4 plus 3 is 7. Those are my terms. All right, so I'm going to go ahead and break this apart here. I'm going to be curving up because this is a positive value there. And the other thing that's interesting is because I have this plus 3, that tells me that at 0, 1, 2, 3, I'm going to shift this curve up 3. This is my shift that happens right here. I'm going to be sliding it up 3 on the y-axis. That's what this point tells me right there. Okay, that value. At 1, I'm at 4, and at 2, I'm at 5, 6, 7, I'm over here. And again, this is going to reflect across the y-axis. So at -1, I'd also be at 4, and at -2, I'd also be at 7. And that's what my curve looks like here. And that's what I have for number 9. Again, it's a positive curving thing. My vertex is here at 0, 3. This would be a minimum. And that's the way that curves there. It doesn't ask for that, but just kind of keep that in mind of how we're doing these things here. Okay? And that's the idea. For number 10, again, we're going to have a curve. It's going to curve up. And because of that -5 right there, we know that when x is 0, 1, 2, 3, 4, 5, y is going to be at -5. So that becomes my vertex for this curve that's going to curve like so when I actually plot that out. And, oh, sorry. That's not true. It's going to curve the other way. My apologies. I was just thinking about the -5. It's going to curve this way. I already said that because it's a positive x squared, and that's the way that's going to go. But it's going to start here at -5 and curve up. So it'll look something like that, and again, plot some values at. For number 11, same kind of idea. That tells me that we're going to shift it down to -1. So we're going to be here at -1. That'll be our vertex point when x is 0. So 0, -1 is 1 point. But the rest of it is going to be curved. We have a fraction, which tells me it's going to be a little bit wider than something else, kind of a little fat shape. And then, because it's a negative, we're going to curve it down. So this one's going to go a little bit wider like that. Again, a little wider curve, something along those lines. Again, that's not correct, but that gives the idea of what it should look like when you make your t-chart for x and f of x and plot some numbers in there. Okay? And again, you only need about 3 of these, and if you do it, you end up with a -1, -1 and 1/3, and a -2 and a third, and you can kind of graph that out however you want to do that. Okay? That's number 11. Let's look on the back side real quick. The back side has a couple word problems that were interesting, and I'm not sure if these will be assigned to you or not, or how exactly your teachers are going to instruct you how to do this. It has a real-life problem. Jared's casting his fishing line with a lead sinker attached over the edges of a pier. The pier is 15 feet above the water. The function, there it is, gives the sinker's height above the water in feet after t seconds. Graph it, and how many seconds does it take for the sinker to hit the water? So what I kind of looked at here is, here's what's happening as a graph. Because we're dealing with time, okay, and height, I know that we're going to start up here at 15. So it's going to start at 15 seconds. At 0, we're at 15 feet above the water, and we're going to move out over time. Now, one of the first things I did, I said, well, what happens at 1 second? If I did 16 times 1 plus 15, I end up with negative 16 plus 15, or negative 1. So that told me that when I got to 1 second out, this sinker line was going to be below 0. I was finally going to be underneath the water somewhere out here. So I'm going to be below the water once I get to 1. That means this curve is going to be, we're going from 15 down to here, but I'm going to have it curved because it's going to be a squared value. So it won't be a straight line from there to there. It's going to have some sort of curve to kind of get there. Okay? I don't know what that'll look like, but it'll be some kind of curvy line like such. Okay? To go from there to there. And that's what it's asking you to find out. But because I saw that it's at negative 1, when I get to 1, I'm already below water, that tells me the answer is going to be somewhere less than 1. Okay, I'd have to figure out what it's going to be. So what I did is I went ahead and said, well, let's say I have I'll do a fourth, a half, and 3/4 of a second to figure out some points along that curve. All right. So when I plugged in 1/4 to this equation, 1/4 squared is 1 over 16. So I have a 16 over 16 is a negative, well, 1/4 is, 16. So I end up with a negative 1. So 15 minus 1 is 14. When I did a half squared, I end up with a 1 over 4. And that's over 16. 16 over 4 becomes a negative 4. And negative 4 and 15 become an 11. And 3/4, I get the same idea there. So 16 goes away. 3 squared is 9. And negative 9 and a 15 gives me a 6. All right, so if I broke this down here, here's 15, maybe this is going to be 10, this is going to be 5, and I have a 1/4 of a second, I have half a second, and 3/4 of a second. So at a half a second, I'm at 14, quarter second. At half a second, I'm at a little bit above 10 at 11. At 3/4 of a second, I'm at 6, and then finally down here. So this would plot out to be something more along the lines of that shape, like that. Not a great graph, but that gets you the idea for how you would solve that one. I will do the same idea with number 13. Again, here, this one here, when I look at it, if I plug in just the value for 1, negative 16 1 second plus 25, I'm at negative 16 plus 25, which is going to be 9. So I want to get to the ground, which is going to be at 0. So at 1, I'm not quite there. So I'm going to have to go past 1. So again, recommendation, go ahead and do a quarter, do a half, do 3/4, do 1, and then maybe do 1 1/4, and see what you come up with for your values there for that grid. It should also look something like we're going to start at 25, and we know that at 1, we're not quite there yet. So we're going to go a little past 1 somehow, and so this is going to again curve down until we get to that point. But you can plug in values to solve what that's going to look like. Okay, next section here. What are the domain and the range? The domain again are the x values, the range are the y values for the function. For all of these equations here, the domain will be all real numbers. Okay, so our domain equals all real numbers for each one of these equations here. My y values, my range is going to be, what I look at here is I look at this term here, because that tells me, remember my graph, where I'm going to have a 0, negative 3, 1, 2, 3. That tells me where my curve is going to be. This is a positive curve, so it's going to curve this way, up it goes, which tells me for this case here, my range is going to be everything greater than equal to negative 3. So I look at that number, I decide if it's positive or less than, positive or negative, and it tells me which way to go. Look at this one here. Again, my domain is all real numbers, that's the same, but for my range, it's going to be, y is going to be, I have negative 2. Okay, so 1, 2, there's my negative 2 value, but because it's a negative 1/4, this is going to curve that way, which means my y values are going to be everything below this point, right? So y is going to be less than or equal to -2, because that's my maximum that it can be. Everything's going to be beneath that point right there. Same on this one. For my y values, we have a positive, which tells me greater than or less than, and there's my minimum here, greater than or less than 1. Here I have a negative value, so the y will be less than or equal to, and there's my maximum, 6. Okay, and again, the domain for all these is all real numbers. And that's it there. Number 18, the difference between this one and that one is that it has this value, which we just talked about. That tells me that on the graph, I'm going to go down to 7, and it's going to shift everything to that -7 point and move everything down to that point. So write that out in words. This is a shift 7 units down is what's taking place in that equation by having that -7 right there. Okay? Explain how you can turn parabolas and shift it up or down by examining the equation. Same idea. We look at that final term, and that will tell you if it's plus, we're going up. If it's minus, we're going down. It tells you the kind of shift we have there. All right? And the same thing finally down here is from a different story. We want to have a graph. We have y equals x squared. If we want it wider and shifted, wider means we're going to have to make it something less than x squared. So I could do half x squared. That's going to be wider. In terms of a shift, right? For the shift to take place, I can add any number, 5, whatever. So when I rewrite this, I can say y equals 1/2 x squared. That makes it wider. Plus 5, I added a shift, and we're good there. All right, that's the homework. Hope that helps you out a little bit and get you going.